All right, guys, another review. Let's go test 14 review. Knock it out. First three actually are inverses. It's asking you where is cosine square root of 3 over 2. These are just values you need to know. Cosine is square root of 3 over 2 at power 6. Second one, where is sine negative square root of 2 over 2? Remember, sine is square root of 2 over 2 at pi over 4. But because it's negative in there, that means, remember, inverse sine, you use quadrant 1 and 4. So to get quadrant 4, we're going negative there. And the last one says, where is tangent square root of 3 over 3? Because there's two threes, it's pi over 6. And because it's positive, it's positive. Number 4, use a calculator to find approximate value of inverse cosine 4/9. First of all, make sure your calculator's in radian mode. These are all radian answers here at the beginning. Just hit the button. Second cosine 4/9. You should see this right here, 1.1102. And number 5, find the exact value of inverse cosine, negative pi over 6. Sometimes we can just like put this down. Sometimes we can just put negative pi over 6 and be done with it. But this time, since it's inverse cosine out here, we cannot use quadrant 4. We have to use quadrant 2 or 1. So what you need to do on this one is do the inside part. Okay, it's asking what is cosine at negative pi over 6? That's quadrant 4. Cosine is positive in quadrant 4. And what is the value? Square root of 3 over 2, just like number 1 up there. Okay, just like number 1. Now it's asking you where is cosine square root of 3 over 2? Just like number 1. It is pi over 6. I don't know if it'll be just like number 1 tomorrow on your test, but like that worked out pretty good there. Simplify. Remember what we talked about this week? When we do the simplify, we're just going to change everything to sines and cosines and go from there. So I have this. I have 1 plus cosine. And in my denominator, I have 1 plus 1 over cosine. Now here we are. We have a fraction inside a fraction. Every time we see that, what we've started doing is just multiplying by whatever your denominator of the small fraction is, the cosine x. I multiplied every term by cosine. If you need to write it by every term, write it by every term. All right, so I get this. I get cosine x plus cosine squared. When I do the top, when I do the denominator, I get cosine x times 1, which is cosine x. And when I do cosine x times that second term, the cosines cancel. I just get plus 1. All right, now, I think I can simplify that some more because I can factor the top. I can take out a GCF, which is cosine. If I take that out, it gives me 1 plus cosine. And oh my gosh, look what's on the bottom. Cosine x plus 1. Those are not opposites. Those are exactly the same thing. They both have positive 1. They both have positive cosine. You can cancel those, and I'll end up with this cosine x. So that's how you simplify that for number 6. Number 7, verify the identity. On these three, we're going to, remember, we're going to try to make the left side become the right side. So I need that left side to be cosecant x. So I'm going to start by changing everything to cosines and sines, which means that cotangent, and cotangent is cosine over sine. That's the only thing I can change. And I have addition and multiplication, which means I'm going to multiply first. If I multiply the cosines together, I get cosine squared over sine x. And the reason that you do that, remember, is that's really cosine x over 1. This multiply the top, this multiply the bottom. That's where you go. Now I'm going to add the two fractions together. My denominator is sine x. If you need to, think about that being over 1. And I'm going to cross multiply the numerators. Okay, so at least that way. So I'm going to go sine squared plus cosine squared. And one thing I should have said at the beginning, because I know I needed cosecant x, in my head I know that means I need 1 over sine. I got to have 1 over sine before I can write cosecant. Look what I got. Sine squared plus cosine squared. Those are the bells and whistles. Okay, 1 over sine x, that is cosecant x. The work, remember, the work is the answer. Number 8, the proof. Number 8, a lot of ways you could go here. You could do FOIL. You could change things to sine and cosine. But, man, I'm seeing these. Like, I'm seeing that thing right there. And, again, bells and whistles. It's a 1 and a cosine squared. If I'm seeing a 1 and a cosine squared or a 1 and a sine squared, I know they're related. So I'm looking at my sheet. 1 minus cosine squared is just sine squared. That's what that equals. And if I'm looking again, it says 1 plus cotangent squared. That's on there also. That's on your identity page. It's cosecant squared. And then you don't have to do this step if you don't want to, but cosecant squared is really 1 over sine squared. All right, now they cancel. You just get 1. You could have stopped right here. Well, I could have put 1 after that step because you're multiplying reciprocals, and when you multiply reciprocals, you do get 1. Number 9, This is a doozy right here. Okay, here's what you need to think about, and you really have to think about this. This says 2 cosine squared minus 1, and I'm trying to get a sine squared. Okay, so one more trick to think about is when I'm going to write this down real quick. Sine squared plus cosine squared is 1. Okay, so what that means is if I need to change this cosine squared to a sine squared, I would just do this. I would move the sine squared over, and look what I get. Okay, so here's the deal. Cosine squared is 1 minus sine squared. All right, so I'm going to do 2 times 1 minus sine squared minus 1. All right, so all I did is I substituted that for 1 minus sine squared because of this that I did over there. Okay, so now let's distribute the 2. If I distribute the 2, I get 2 minus 2 sine squared x minus 1. All right, 2 minus 1 is 1. Minus 2 sine squared x. And I just didn't notice something. That was a typo. That should have been a 2 right there. And I didn't do that because that's what I got. I remembered once I started the problem. When I made your answer key the other day, there's one on your test that is very much like that. Okay, here's a secret. This one's on your test. Number 9, same problem. Okay, let's keep going. Number 10, find the 6 trig ratios for the triangle. You can't do that without finding the third side first. So, I got 7 squared plus, b squared equals 8 squared. That's 49 plus b squared is 64. I'm just going to do some quick work in my head. That's going to be b squared is 15. So b is square root of 15. Right there. Okay, so here we go. Sine theta. Sine opposite over hypotenuse, which means cosecant is the reciprocal. Cosine theta is adjacent over hypotenuse, which would be square root of 15 over 8, which means secant is 8 over square root of 15 or 8 on 15 over 15. Tangent's opposite over adjacent, which would be 7 over square root of 15, also sine over cosine, which should be 7 on 15 over 15. And the last thing, cotangent. Got to flip tangent. I'll flip the first one. It's much easier. Square root of 15 over 7. There's those 6. Number 11, solve without using your calculator. Here's the values you know. Okay, so here I go. Sine power 4 is square root of 2. Cosine 2 pi over 3, that's quadrant 2. That's negative 1/2. So I'm going to multiply those two. Minus cosine power 4 square root of 2 over 2. Sine 2 pi over 3 is quadrant 2, but it's positive. And then I'm going to multiply that out and then square everything. Okay, so the square at the end is the big deal. So if I multiply the first two, I get negative square root of 2 over 4. Second two, I get negative square root of 6. Well, it's minus square root of 6 over 4. Now I'm going to go ahead and do this because they both have 4s. I'm going to make it one big fraction here. And I've got to square that thing. Okay, so here it goes. If you square the 4 on the bottom, you just get 16. No big deal there. On the top, that's going to be square, multiply, double square. So if I square negative square root of 2, I get 2. If I multiply these together, I get positive square root of 12. And if you double it, you get a 2 in the front. And it's positive because negative times negative. And then if I square the negative square root of 6, I get a plus 6. So I'm going to simplify this stuff. This problem seems like it's going to take forever. Let's go, though. So I have 2 and 6 is 8. 12 you can break down. 12 is 4 times 3. So I'm going to take the 2 out with that 2. That gives me 4 on 3, all over 16. And because all those numbers are multiples of 4, I'm going to take a 4 out of the 8, a 4 out of the 4, and a 4 out of the 16. And there you have it. Even if you used your calculator, you couldn't get that answer because this is the exact answer. You got to have that square root of 3 in there. Now, to what you can do, you can, I don't know why I put plus or minus. Good not. You could take your calculator and go 2 plus the square root of 3, and then divide it by 4, and then punch all that in at the beginning and see if you get the same number. But that seems like a lot of work to check your answer, but you can. All right, number 12, solve the triangle. I was thinking about this. I think I'm going to have you, instead of solving the triangle, just find the missing part, where the x is. Figure out the best way to go there. Here's what I know. I know what angle C is by subtracting those from 180. So I'm doing 180 minus 52. The reason I'm finding that angle C, even though they didn't ask me, if I know that angle up there is 58 degrees, then I can do law of sines. So I can say sine of angle C, which is 58, over side C, which is 26.7, equals sine 52 degrees over x. And on your test, I'm just going to have you find that. Instead of doing the whole entire triangle, let's just find whatever's missing, whatever they ask you, whatever the x is. Okay, so let's cross multiply. I'm going 26.7 times sine 52. Oh no, I'm in radians still. Let me go change that real quick. Make sure you're back in degree mode here. So I'm going, get out of there. Okay, 26.7 times sine 52. Divide that by sine 58. I'm getting 24.8. So that x right there would equal 24.8. And we won't do the whole triangle. We'll just do whatever they're asking us for. All right, 13. 13 is a radical equation. You got to isolate the radical first. So moving the 1 over there, that gives me this, 5 minus x inside, and x minus 3. Got to square both sides. Remember, we're squaring both sides. So if I square the radical, it's gone. Here I'm going square, multiply double square. And I got to factor that. I hope I can factor it. So moving the x over, it gives me negative 5x. Move the 5 over, it gives me plus 4. Thank goodness. All right, so I can factor that, x minus 4, x minus 1. So my two answers are 4 and 1 maybe. Plugging those back in. The 1 does not work for sure. The 4 is good. All right, last one, 14. Find the inverse of that. So a couple steps here. Switch the x and the y. Like that. And because you have two y's, it's going to take a second. I'm going to cross multiply first. It gives me xy plus 2x and y minus 2. Got to get your y's together. So let's switch places with those two terms. Xy minus y. Move the 2x over. Now here's the key step. Because I have two y's, I need just one y. I'm going to factor out the y. If I factor out that y, that leaves me x minus 1. It equals all this over here, that negative 2x minus 2. So to finish up, just divide both sides by x minus 1. I get negative 2x minus 2 over x minus 1. There's your inverse. All there is to it. Man, I hope you do good tomorrow or today, whenever it is you're watching this. And come see me if you need me. I'll be glad to help you. I'll see you then.